In this video, I'll be discussing about probability of dependent, independent events as well as the conditional probability. Let us take the first one, the probability of independent events. Events are said to be independent if the outcome of one event does not change the probability of the other event happening or occurring. The logic is the second event is resets or is completely unrelated to the first one. And as for the formula, for the two independent events denoted by A and B, we have the probability of event A and event B is equal to the probability of A times the probability of B, or event A and event B. Now, para maintindihan natin to, let us consider this illustrative example. Particularly the probability of tossing a coin and rolling a die. If you flip a coin and roll a six-sided die, the coin landing on heads has no impact on whether you roll a four-dotted face of a die. Now for our solution, suppose when you flip a coin, a head came out. So what is the probability of flipping a coin where a head will show up? That is 1 over 2. And at the same time, we roll a die. And upon rolling a die, a four-dotted face will come out. So what is the probability? So the probability is 1 over 6. And as for the combined probability, applying the formula, that is simply the product of the probability of these two events, A and B. So we just simply get the product of these two obtained probabilities. That is 1 over 2 times 1 over 6. And we have 1 over 12, which is our answer. So this is the probability when you flip a coin and at the same time you roll a die, a head, and a four-dotted face will come out. Okay. Now let us have the other one, the probability of dependent events. Events are said to be dependent if the outcome of the first event affects the probability of the second one. This usually happens when the pool of possible outcomes or the sample space changes. Okay. Now this is the idea for the probability of dependent events. Take note of this term, the without replacement phrase. So, such phrase rule is the classic sign of dependency. Now, and as for the formula, we have this one. Okay. The probability of A and B is equal to the product of P of A times P of B happening given that A already happened or already happened. So when it comes to this part, you are going to properly read this as the probability of B occurring when occurring given that event A has already happened. For example, let us consider the probability of drawing marbles. Now suppose we have a bag containing 3 red marbles and 2 blue marbles. So if we get their total, we have a total of 5 marbles. Now suppose you draw 2 marbles without putting the first one back. So dito yung nandito yung idea ng without replacement. You pick one ball and you are not going to return that ball upon drawing another one. So again, you draw 2 marbles without putting the first one back. So ano mangyayari? Now for an event A, you pick the first red marble. So what is the probability? Now from the given, there are 3 red marbles. So you simply consider 3 red marbles, or that is P of A, is 3 divided by the total number of marbles, which is 5. So that is 3 over 5. So that is the probability of picking the first marble. So that is your P of A. Now, and as for the P of B, or for the event B, which is drawing the second marble, you need to consider that the sample space is no longer 5. Okay? Since you are not going to return the first red ball, it means the number of the remaining red ball is now 2. And as for the sample space, it is not anymore 5 but 4. Okay? So, for the second event, you pick the second red marble. So that is your P of B, given that A already happening. So, ibig sabihin, yung outcome ng event B ay nakadepende sa nangyari sa outcome ng event A. So, now, referring to the given, the mere fact that you did not return the first red ball, so the remaining number of red ball is no longer 3 but 2. So that is 2 over the number of sample space is also decreased by 1. So from 5, that is 4. So reduce the result to its simplest fraction. So from 2/4, it becomes 1/2. Then for the combined probability, that is simply following the formula, the product of picking the first marble, which is P of A, and picking the second red marble, wherein the first marble is not returned. So we have 3/5 times 1/2. And the product is 3/10. Okay? Next. How about the conditional probability? It is likelihood of an event occurring even given that another event has already occurred. It focuses your attention on a specific subset of the data. Now, for the formula, we have P of A happening given that B already happening is equal to the probability of the intersection of the two events A and B over the probability of event B. Now, so you read this. This is how you properly read the formula. The probability of A given B is the probability of both happening divided by the probability of the condition B. Yan. Pwede ganon. Now, for our example, let us consider the class survey situation. Now, suppose in a class there are 100 students. From this number of students, 40 students are in the art club. So that is your A. And 30 students are in the drama club, which is your B. And then 10 students are in both clubs. Okay, so it means 10 students are involved in both clubs, the art and drama clubs. So that is your A intersection B. Now, if you pick a student at random and find out they are in the drama club, what is the probability they are also in the art club? So, for our solution, let us list down the given information or compute for the probability involved in this situation. So let us take the probability of the intersection of the two events. So from the given, for the intersection of two events, that is actually the number of students who are in both clubs, and that is 10 over the sample space. It is already given. How many students are there in a class? 100. So that is over 100. Okay, you can simplify this, or you can consider that value without simplifying first. So we go now to the second value, the probability of event B. That is number of students in a drama class. So how many are there? So 30 to be divided by, again with the sample space, 100. Then for the value of this one, P of A happening, given that B is happening, okay, so that is what we're going to compute. So using the formula, we substitute. So the probability of the intersection of the two events, that is 10 over 100 over the probability of B, which is equal to 30 over 100. Simplifying this complex fraction, we can cancel the common 100, and what will remain is 10 over 30. We know that the common factor between the two is 10, so the result is equal to 1 over 3, 1/3.